Hello, my dear students. Previous class we discussed what is matrix, the order of a matrix, the general form, the general representation of matrix, and elements representation of matrix. Now we will discuss the types of matrices and the equality of matrices. First, we discussed types of matrices. There are different types of matrices. Let's start. Number one, row matrix. Row matrix. First, row matrix. A matrix if a matrix have only one row and any number of columns. Row matrix means a matrix have only one row and any number of columns. That matrix is called row matrix. For example, 1, 2, 3. Here the order, the number of row is 1 and number of column is 3. Therefore, this matrix is called row matrix because the number of row is 1 and the number of columns is 3. Therefore, a matrix which have only one row and any number of columns, that matrix is called row matrix. For example, A equal to 1, 2, 3 of order 1 by 3. Next, column matrix. What is column matrix? A matrix have only one columns and any number of rows. That matrix is called column matrix. For example, A equal to 1, 2, 3 of order 3 by 1. The definition of column matrix: a matrix is called a column matrix if the number of row, the number of columns is 1, the number of columns only 1 and any number of rows. For example, A equal to 1, 2, 3 of order 3 by 1. Next, rectangular matrix. Rectangular matrix. What is rectangular matrix? A matrix if number of rows is not equal to number of columns, that is M is not equal to N. M means number of rows and N means number of columns. M means number of rows and N means number of columns. If M not equal to N, that means number of rows is not equal to number of columns. That matrix are called rectangular matrix. For example, A equal to 1, 2, 3, 4, 5, 6 of order 2 by 3. If a matrix, the number of row is not equal to number of columns, that matrix is called rectangular matrix. For example, A equal to 1, 2, 3, 4, 5, 6 of order 2 by 3. Here total number of rows is 2 and the total number of column is 3. Therefore, that is M is not equal to N. That matrix is called rectangular matrix. Next, number 4, square matrix. Square matrix. If number of rows is equal to number of columns, that is M equal to N. M means number of rows and N means number of columns. If number of rows in a matrix, the number of rows equal to number of columns, that matrix are called square matrix. For example, 1, 2, 3, 4 of order 2 by 2. This matrix is called square matrix because the number of rows is number of columns. Here the number of row is 2 and number of column is 2. Therefore this matrix is called square matrix. Next, number 5. Number 5, null matrix. Null matrix. Null matrix. If a matrix whose all elements are 0, a matrix is called a null matrix whose all elements of this matrix is 0. That matrix is called null matrix. For example, 0, 0, 0 of order 2 by 2. This is called null matrix. Here the all elements of this matrix are 0. The all elements, these calls are elements, and all elements of this matrix are 0. Therefore this matrix is called 0 matrix. Or we take another example, 0, 0, 0. This is called 0 matrix of order 2 by 3. In general, the 0 matrix, the null matrix or 0 matrix is represented in the capital letter O. The null matrix is represented the capital letter O. Next, diagonal matrix. Diagonal matrix. What is diagonal matrix? A square matrix. A square matrix if the all elements of the diagonals are not 0, are non-zero, and non-diagonal elements are 0. For example, A equal to A 0 0 0 B 0 0 0 C. A square matrix is said to be diagonal matrix if the diagonal elements, this is called principal diagonal. The diagonal elements here, the diagonal elements are A, B, C. The diagonal elements are non-zero. The diagonal elements are non-zero. Here A, B, C is non-zero, and the non-diagonal elements, this, the non-diagonal elements are 0. That matrix are called diagonal matrix. For example, A equal to A 0 0 0 B 0 0 0 C. A square matrix if the diagonal elements are non-zero and the non-diagonal elements are 0, that matrix are called diagonal matrix. Next, number 7, scalar matrix. Scalar matrix. Scalar matrix. What is scalar matrix? A diagonal matrix are said to be scalar matrix if the all diagonal elements are same and non-diagonal elements are 0. For example, A equal to the all diagonal elements are same and non-diagonal elements are 0. Here the diagonal elements, this is called diagonal elements, principal diagonals, and the diagonal elements are same A, and non-diagonal elements are 0. This matrix is called scalar matrix. The definition of the scalar matrix is a diagonal matrix is said to be scalar matrix if the all elements of the diagonal principal diagonals are same and non-diagonals elements are 0. Next, number 8, unit matrix or identity matrix. Unit or identity matrix. Identity matrix. Unit or identity matrix. If a diagonal matrix, if the all the diagonal elements are equal to 1 and non-diagonal elements are 0. For example, generally diagonal elements are denoted by I, capital letter I, 1 0 0 1. in a diagonal matrix, the all principal diagonal elements are equal to 1. That is 1, 1. The all principal diagonal elements are equal to 1, and non-diagonals elements are equal to 0. That matrix is called unit or identity matrix, and it is the identity matrix are denoted by capital letters I. Is order 2 by 2. We take another example. I3 equal to 1 0 0 0 1 0 0 0 1. This is also called diagonal elements of order 3 by 3. Now I repeat. First, the types of matrices. First, the row matrix. The row matrix means a matrix have only one row. That matrix is called row matrix. For example, A equal to 1 2 3 is a row matrix of order 1 by 3. Next, column matrix. Column matrix means a matrix have only one columns and any number of rows. That matrix are called column matrix. For example, A equal to 1 2 3 of order 3 by 1. Next, rectangular matrix. Rectangular matrix means the number of rows is not equal to number of columns. In a matrix, the number of rows is not equal to number of columns. That is, M is not equal to N. The number of rows is not equal to number of columns. That matrix are called rectangular matrix. For example, A equal to 1 2 3 4 5 6 is a matrix. It is a rectangular matrix of order 2 by 3. Here the number of row is 2 and number of column is 3. Therefore, this matrix is called rectangular matrix. Next, square matrix. If a matrix have equal number of rows and equal number of columns, the number of rows equal to number of columns, that matrix are called square matrix. For example, A equal to 1 2 3 4 is a square matrix of order 2 by 2 because the number of row is 2 and number of column is 2. Therefore, M equal to N. Next, null matrix. A square matrix. Null matrix means a square matrix whose have a matrix whose have all elements are equal to 0. A matrix whose all elements are equal to 0. That matrix are called null matrix. For example, this and this. Next, diagonal matrix. A square matrix. A square matrix is called a diagonal matrix if the principal diagonal, this is called principal diagonal. The principal diagonals elements are non-zero. This is non-zero and non-diagonal elements are 0. That matrix are called diagonal matrix. Next, scalar matrix. A diagonal matrix are said to be scalar matrix if the principal diagonals are equal to 1. That means A that are equal. And non-diagonal elements are equal to 0. That matrix are called scalar matrix. Next, unit or identity matrix. A diagonal matrix are said to be unit or identity matrix if the principal diagonals are all elements of the principal diagonals are equal to 1 and non-diagonal elements are equal to 0. That matrix are called identity matrix. Now we discussed equality of two matrices. Equality of matrices. Now we discuss equality of matrices. Let A is a matrix of order m by n and B is a matrix of order p by q. Let A is a matrix of order m by n and B is a matrix of order p by q. That means number of row is p and number of column is q. Are equal if Number 1, the number of rows in A is equal to number of rows in B. That is m equal to n. Because the number of this matrix, the number of rows is equal to m, and this matrix, the number of rows is equal to q. Therefore, condition 1, m equal to n. This A and B are equal if the number of rows is equal, the number of rows in A equal to number of rows in B. That is m equal to n. Condition 2, number 2, the number of columns in A is equal to number of columns in B. That is n equal to q. If the number of columns in A is equal to number of columns in B. That is n equal to q. Third condition, the corresponding elements are equal. That is Aij equal to Bij for all I, j. Let A and B are two matrices of order m by n and p by q are respectively. The two matrices are equal if and only if the number of rows of matrix A is equal to the number of rows in the matrix B. Number 2, condition 2, the number of columns in matrix A equal to the number of columns in the matrix B. That is n equal to q. Third condition, the corresponding elements are equal. That means Aij equal to Bij for all I, j. Now we discuss some problems in exercise 3.1. Exercise 3.1. Previous class we discussed question number 1 to 5. Now we discuss question number 6. Find the values of x, y and z from the following equations. Number 1, 6, Roman number 1, 4, 3, x, 5 equal to y, z, 1, 5. Find the value of x, y, z if this and this matrix are equal. We know that if two matrices are equal, if and only if the number of rows of this matrix equal to the number of rows of this matrix, and number 2, the number of columns of this matrix equal to the number of columns of this matrix, and last condition, the corresponding elements are equal. Since this and this are equal, this matrix and this matrix are equal, therefore we can write y equal to 4, because we know that if two matrices are equal, then the corresponding elements are equal, therefore y equal to 4 and z equal to 3 and x equal to 1. Roman number 2. Next, x plus y 2 5 plus z xy equal to 6, 2, 5, 8. Find the value of x, y, z if this and this are equal. We know that if two matrices are equal, then the corresponding elements are equal. Therefore, we can write x plus y equal to 6 and 5 plus z equal to 5, 5 plus z equal to 5 and xy equal to 8. equation number 1, equation number 2, and equation number 3. From equation 2, z equal to 5 minus 5, therefore z equal to 0. From equation 2 we have z equal to 0, z equal to 5 minus 5, that is z equal to 0. Next, from equation 1, x plus y equal to 6, therefore y equal to 6 minus x, equation number 4. Equation number 1 given x plus y equal to 6, therefore we can write y equal to 6 minus x. This is equation 4. Solving from equation 3 and 4 we have, solving equation 3 and 4 we have y equal to 6 minus x, 6 minus x equal to 8. Equation 3 xy equal to 8, and equation 4 y equal to 6 minus x. Putting the substituting the value of y in equation number 3, then we have x into y equal to 6 minus x, therefore we substitute the value of y, x into 6 minus 8 equal to 8. Then we have 6x minus x square equal to 8, therefore x square minus 6x plus 8 equal to 0. Now we find out the value of x square, 8, 4 to the 8, 4 plus 2, x plus 8 equal to 0, that is x square minus 4x minus 2x plus 8 equal to 0. X minus 4 into x minus 2 equal to 0, therefore x equal to 4 and or x equal to 2. By using the factorization formula, we have, after solving, x equal to 4 and x equal to 2. If x equal to 4, then if x equal to 4, then we have y equal to x equal to 4, 6 minus 4, then y equal to 2. If x equal to 2, then y equal to x equal to, putting the value of x equal to 2 in this equation, y equal to 6 minus 2, then y equal to 4. Therefore, if x equal to 4, then therefore x equal to 4, y equal to 2, and z equal to 0, or x equal to 2, then y equal to 4 and z equal to 0.